What is reversibility? When a perfectly reversible process is done, no work is lost due to disorder. Often engineers use this theoretical perfect process as a first estimation in order to understand a real process. One way to think about reversibility is to see if a process can be completely undone. Here, we want to see if baking brownies is reversible. We'll add all of our ingredients. We have our mix, water, oil, and an egg. If this process were reversible, we could reverse our mechanical work, but as we stir, we convert our mechanical work into randomness, friction, and a small amount of potential and kinetic energy. To test if this process is reversible, we will stir the batter in the opposite direction and hopefully get our ingredients back out. As we can see, that's not happening. If this were reversible, this is what our batter would look like.
Here is an example of reversible driving, where we are getting as much work out as we are putting in. This moving car, however, is slightly reversible because we are putting work in but only getting some but not all of the work back out. This car is going through a completely irreversible process. Lots of work is being put in, but no useful work can come back out of this process.
And now it's time for a thermo-turbo lecture. Reversibility is related to, but different from, entropy and efficiency, or the ideas of entropy and efficiency. Engineers, like me, use it to approximate the amount of work they can get out of a system, like a pump or a compressor. The ratio of work actually achieved to the maximum you can get out if the process was reversible is the efficiency. We write that as nu is equal to the work from a real-life process over the work from a reversible process, which can never be more than 1. So if somebody claims that they have a reversible 100% efficient system, call them a liar. Now that means you, thermo fans, it's up to you to correct the mistakes that people who don't know what they're talking about make. Now, what makes something irreversible? Well, these things are called gradients. Well, what's a gradient? A gradient is a difference in some property between two different things, like velocity, temperature, and so on and so forth. We can approach reversibility by first neglecting some work-dissipating forces like friction and viscosity, and 2, pretending that the gradients are really, really small. All right, so for example of this process, we're going to take the case of blowing up a balloon outside, which is typically not a reversible process, but we're going to pretend that it is for this experiment. It's an expansion process where we go from volume 1 to volume 2. Now the work is modeled by the pressure times the volume. Now we want to look at very, very small changes in volume, derivative volume called dV. This is a very, very small gradient that we're going to add up over a large period of time, and that's how you approximate a reversible process.